Hello and welcome to today's episode of the Exposure Scientist podcast. Today we are going to be discussing microplastics as there has been a renewed and increased focus on them in the news and other research publications. Before we get there, just a quick reminder on our new website for the Exposure Scientist podcast, we have a new feature that will enable you to go leave a message for us, a message that we can play on the show or listen to, or comments or questions that we can incorporate into the podcast. So please go check it out, leave some comments, leave some thoughts. We'd love to test out this new feature and incorporate any comments that you may have into a product at the end of the show where we have some question and answer time following the podcast. So again, I mentioned today's subject is microplastics. And I've seen a renewed focus on these in inquiries that we have received, as well as publications and news articles. So I think it's important to at least kind of generally talk about. EPA recognizes that there's microplastics. They call them microplastics. Sometimes they're called nanoplastics. Sometimes they're called micro nanoplastics, depending on who's using it or where you're looking. But, they follow along certain, I'll say, size fragments, and potentially the smaller the fragments, the more surface area they have, the more impact they may have. Generally, when you're looking at nanoparticles, they have a higher surface to weight ratio or surface area ratio, and that causes maybe a more of an increased potential for interactions. So some of the news articles that I have seen on microplastics lately surround the use of them or identification of them. Recently, I think there was a cardiovascular conference where they discussed detection of these and detection of microplastics within the plaque formations within arteries, and saying, hey, look, these were associated or these were found in these plaques. It's important to understand and contextualize all the information that we are going through on here for identifying, okay, well, what are the potential hazards and what are the risks? So the four steps in the risk assessment generally are hazard identification, exposure assessment, toxicity or dose response assessment, and risk characterization. So we're at the first step. Hazard identification. Are microplastics a hazard? And that's an interesting question. I think it's important for anything that we do. And just to emphasize this is I've seen this, and I've had clients ask this, and we just have to continually remind them. Science, the scientific method, scientific process is not a fast process. I think we all know that. It's not something that can be done overnight or within a week. There's a process for doing this. There's a process for understanding, evaluating, looking at the data, gathering the data, identifying whether or not it's a hazard. Now we can use something called the precautionary principle and say, hey, if we think it's definitely going to be a hazard, let's put a hold on it. Let's do some protective measures, and then we'll generate the data. But I don't know if we're there yet, so I'll present some of the information. Now, to give this some context, I'm going to give you, I'll say, some headlines and some news articles that I've seen. And remember, whenever we're talking about there is the exposure, what people are being exposed to, what is internalized, and then we have to figure out what this stuff may be doing to the body, if at all, how fast it gets out of the body. There's lots of things that go into toxicological assessment of an exposure. And again, science is not fast. So again, some of the news articles that I've seen, I'm just looking at them now. They're talking about microplastics in marine life, microplastics found on beaches, drinking water having microplastics in them, microplastics in the food chain found in fish. Looking at actually, this one is involving seals and looking in seal stomachs to see what may be in there. There's lots of information about microplastics, the presence of them within, I'll say, the food chain. Now, one of the questions is, if they're in the food chain, do they what's called bioaccumulate? Is there an additive kind of, is it in one smaller thing, and a small fish, and then the bigger fish eats that, and those microplastics stay in there, and then maybe a human eats that fish, and then we get all the microplastics that were both in the smaller fish and in the larger fish. That is something I think we're still probably attempting to identify. EPA, if you go to the website, search EPA microplastics, they have, hey, research is going on to figure out what are the potential health risks. Because right now, I don't think there are any that are really established from a health risk perspective. There have been some studies, a lot of studies have been published in 2025 surrounding microplastics. There were some at the end of 2024, but again, it's got a big focus right now. There's some that talk about the presence of microplastics in the brains of people who have passed away, and they are doing autopsies on them and identifying what's in them. They have identified that there's some studies that have identified microplastics in blood. Again, I mentioned the one study from the Cardiovascular Association, cardiovascular presentation that talked about the presence of them on plaques, arterial plaques, looking at microplastics in the lungs, what may be from either inhalation or other exposures. There have been discussions of microplastics that are in the liver, as well as a digestive tract, of course, from eating them. There's even a study that talks about microplastics from disposable face masks. So there's lots of studies evaluating them. I may have mentioned this in the previous podcast. There have been some studies that have attempted to identify what the potential health risks are. But what are the health risks? So what are we looking at? So in generally, we talk about these things that are called biomarkers of exposure, which say, hey, these people have been exposed. We may be able to use microplastics as a biomarker of exposure. What is a biomarker of effect? Well, it's something that changes as a result of the exposure, whether it's a level of a certain enzyme or whatever it is to show that the body is reacting to what's it's encountering. Some studies have attempted to use what we call cell lines or generally petri dishes on a laboratory top that says, hey, we're putting these in these cells and seeing what happens. And that's good. That's fine. That's interesting. That you have to make sure that these are reproducible studies, as in I'll say they're generally accepted methodologies that are easily reproducible. Some studies have standard guidance for them. Some of them are just kind of, hey, we're doing this as research purposes. It's important to understand the difference between the two. Is this something that is done in what was called a good laboratory practice? They have all these safeguards in place, or is this done in a benchtop in a research laboratory where sometimes things are not done the same way every time? And that's important context. A. B, what are the exposure mechanisms? So if they're exposing cells and saying, hey, these microplastics kill these cells, you have to understand that we are more than just cells in the petri dish. We are complex organisms, animals, what have you, are complex organisms where different types of cells are interacting all the time. It may be where, fine, we have exposures, but our body's goal, if something's not supposed to be in there, or if our body has used up what's in there, our body's goal is to get it out. That's what we do probably multiple times a day, is we take stuff in and we get it out. We use what we need and we're done with it. Same thing with other exposures. If our body doesn't want that in there, doesn't need anything from it, doesn't benefit from it anyway, we're getting it out. Now, sometimes certain chemicals or certain constituents or substances may stay in our body longer than what we'd want. Some of them get out pretty quickly, depending on how our bodies are used to addressing and handling them. What are microplastics? Well, I'd say there's limited amount of studies to see how quickly they get out of our body. There's been some studies that have evaluated the presence of microplastics in urine. Is that something that shows that our body is attempting to get it out in a fast way? That's something that's still being evaluated. How fast does our body get it out? But is our body interacting with it? How is it interacting? Is it a chemical reaction? What type of plastic it is? Now, I think it's important to know that there are different types of plastic out there. And when you use the term plastic, it encompasses a number of different, I'll say, types of materials. Are they all the same materials? Are they all materials reacting the same way or being eliminated the same way? Do some eliminate in a different way than others, or some have any different effect than others? Are you able to differentiate those, or what we call speciate them? That's something that's going to need to be determined. Like the health effects, if any at all, are going to have to be determined. What are the health effects beyond just petri dishes? What are the data showing us? We may have exposure, but what are the exposures detrimental? Is it just something that's going to exist? Where are the exposures coming from? There's some that theorize that maybe they come from medical devices that are implanted. Some I saw that said, hey, maybe they use some stents that are in place within the body. Maybe that's the source of the microplastics. There's some that I saw discussing uh, needles when you're doing an injection. They're finding it in the body. There may be plastic that comes from the needle. I think that's all things that need to be evaluated and determined as research progresses. I'm not sure if the research is there yet on what the actual human risk is. We see that there are data that establish there is exposure. What is the risk, if any at all? So far, the studies that have been published that I review within, I'll say, the last few months or the early months of 2025, as I sit here today recording this, don't go so far as to establish human risk or adverse health effects from exposure. Are we going to get there? We may. Are we going to do anything to limit the exposure to these microplastics? Perhaps. There's another podcast I gave recently that discussed the know what's in your product before someone tells you what's in there. Are manufacturers going to start looking for the presence of microplastics, determining what causes them to occur, mitigating them? It goes with the thought of are there benefits outweighing the cost of exposure? Is the exposure doing anything harmful? Is it just the presence of it and our body's getting rid of it? These are answers that we're going to have to go through. There's been some studies that have looked at um, manufacturing, people in the manufacturing realm of plastics to see what their exposures are. And those are hard too, because plastic is everywhere. Think about how many things you interact with on a daily basis that are plastic right now. My keyboard, my mouse, my chair, plenty of things in my truck, plenty of things within the house, within the bathroom. I got plastic containers that I take mouthwash out of. I got plastic tubes that contain toothpaste. I use a plastic toothbrush. What are the sources of the microplastics? Are we able to do a study that's going to actually reflect where the source of those microplastics are? Just sit down and think, make a list of things that you can think of every day from products that you're using and where microplastics come from. How are you going to change that? Is it worth changing? These are all questions that we have to ask. I'd love to hear your thoughts on this. Have you asked some questions, bring up some things that you've maybe thought about, but there's an increase over the last 20 or 30 years of using more and more plastic products. Are these plastics accumulating from that use? Can we see a trend? I think I mentioned in another podcast of, hey, maybe years ago, we couldn't even at a laboratory level detect these types of materials. But now our laboratory instrumentation is so we're seeing lower and lower levels and we can actually see these things, whereas before we couldn't. So are we able to see a trend in use of these products, a use of a particular plastic? There's a lot of questions here, and it's going to take some time to get the answers. And I think that dedicating some time to answering these questions is going to be important. So if you have any comments or questions, I'd love to hear from you. Again, try our new website with a comment feature that's turned on and see if you have any other thoughts or just a different viewpoint on this. I appreciate you joining us on today's episode of the Exposure Scientist podcast, and I hope to listen to you and hear from you soon. Thank you.